Star Wars memorabilia has 13 Rebel collectibles, so we have 13R and 8 Imperial collectibles. All of these are different, so that's an interesting fact, right? They're different, so we don't have to worry about identical objects. So that's why this was said specifically. He would like to choose a group of 4 to be displayed. Choose a group of 4 to be displayed. If the 4 are chosen randomly, what's the probability they are all Rebel collectibles? First of all, remember I told you, is it number of, is it odds, or is it probability? It is probability. So we are expecting, we should be thinking this is going to be NA over NU, right? So let's figure out NU. That's usually the easiest one. So I have a total of 21, right? 21 total. So I'm going to choose, from the 21, I'm going to choose 4. I'm going to figure out how many groups of 4 can I make. And here it is. It's 5,985. And then the NA is that they're all Rebel collectibles. So we just want the Rebels, right? So from the 13, we choose 4, right, to make our entire groups. And I like you to think about still that they're both there, but this is going to be 1, right? So 13 choose 4 is 715 times 1, that's just 715. Okay, so how about today we'll make this a little different. We'll say that gives you 1 mark, that gives you 1 mark, and then stacking them will give you another mark. And make sure that the bottom number is always greater than the top. If that's not the case, you're going to lose a mark because you should be catching that. So 3 marks for, get rid of the 2 here, just say this is out of 3. Okay. If the 4 are chosen randomly, what's the probability we're choosing? We're not, listen up to this, guys, we're not lining up for a picture, we're not arranging, we're not saying how many ways can they be principal or president, vice president, and so forth. Like we're not, order doesn't matter here. Selecting, choosing 4, right? We're not having specific positions, so this is combinations for that reason. And here's that other word, or the at least, right? What's the probability of at least one of them being an Imperial collectible? And there's the word probability again. You've already done the hard, like one of the pieces of the universal is done, okay? So we're already confidently going to say whatever happens, it has to have that universal down here. We figured out how many groups are possible, right? So now we're going to figure out NA. We want at least one of them. So you want to be thinking total minus no Imperials. Because if you do that, you figure out at least one or more. Okay? So we're going to go 21 choose 4, that's my universal, minus no Imperials. So that would mean, can I use my previous answer? I can use this answer. So I'm just going to use the 715, but I will show that I'm taking away all the groups that have no Imperials. Like from the 8, I choose 0. So I'm just going to have a group of 4, and they're all from the Rebels. Okay? So that's 5985 minus 715. Oops. That's 5270. Is that what we get, guys? 5270, a few knots, okay? And for today, we're just going to leave it like that because technically you get full marks there, even if you didn't reduce it. So this is your answer here. Okay, keep going. If 4 are chosen randomly, what's the probability of having exactly half of them are Imperial? So sometimes the wording is a little tricky maybe, but half means 2, right? Having 2 and 2. 2 imperial, 2 of the other one. So in this case, maybe I will do this, NA. From the 13, I'm going to choose 2, and from the 8, I'm going to choose 2 as well. I need to have my group of 4. So 13 choose 2 is 78. 8 choose 2 is 28. If I multiply that, it's 2184. So that would be my NA. That's the top number. So probability is 2184 over 5985. Okay, there you got it. Okay? Keep going. In a phys ed class, there are 25 students being divided into groups of 5. So I think this is interesting here, groups of 5. Andre and Clark. Sorry, Clark, I wrote this before you were in my class, but I think you're okay with that, right? Some publicity for Clark here. Andre and Clark are in the class and hoping to be in the first group. What's the probability that Andre, sorry about that typo, and Clark are both picked for the first group of 5? Well, let's do the NU here. 25, choose 5. That is it, right? That's my universal. So that's 53,130 groups that can be created. NA, now we're going specific. What do you think? If it's the 2, Andre and Clark, we've done this type before. From the 2, I want to choose all 2. And how many remain? Out of the 25, 2 are already taken out, right? Andre and Clark. So that'd be 23. Choose what? 3. Because I need to have my group of 5. And I need to have my total of 25, right? So everything checks out. Like this is 25. And this is 5. So we're still back to 25, choose 5 in a sense, right? Like you're still making sure that all 25 are taken care of and they're all considered. So this is 2 choose 2 is just 1. 23 choose 3 is 1,771. So that's just that, right? So probability, it asks for probability. So 1771 over 53,130. I'm just going to say this. I do a lot of probability today because we're reviewing probability. But I could have easily just asked you how many groups are there where Andre and Clark would be included. Your answer would have been just that. Like just this. That's the number of groups that have Andre and Clark in them. Okay? How many groups can be made in total? That's it, 53,130. But if you see the word probability, you need to take it a step further. You need to have NA and U stack them. Okay? Usually 2 marks. Probability is usually worth 2 marks unless you can grab from previous answers. Then they usually go down to 1. And here's this one. Pathways, right? Andra lives in the area. On the grid, she walks her route between home and work. So home and work with random lefts and rights. So as long as she always goes towards her destination, never further away along her route, there's a convenience store. Along her route, there's a convenience store. Whenever she passes the convenience store at random, she buys an ice cream treat there. What's the probability that on a random day, Andrea buys an ice cream treat? So basically, what's the probability that she'll actually make it go through the store? Okay, so probability, we're going to go NU first. NU, going from home to work, is simply home to work. That's all we need. Okay, so let's figure that out. I hope you're okay with going up and left. Okay, up and left. So it doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9 factorial over 3 factorial, all the north, right? North, and then there's 6 going this way. So these 2 numbers, but down here, should add up to whatever you have in the top. That's very important. So 9 factorial is 362,880. 3 factorial is 6 times 6 factorial. Is it 4320? That's 84. 84 total ways to get from home to work, as long as you ignore the store for now. And then the NA comes in. That's when you just want to consider. All of a sudden, this turns into a question where there is one bottleneck. So for NA, we're going to go from home to the store and from the store to work. That's what we're considering. We're multiplying them. So from home to the store, there's 4 factorial, and then there's 2 factorial, right, for that one, 2 and 2. You can see that, right? And then it's 1, 2, 3, 4, 5. It's 5 factorial to go from the store to the workplace, and then it's 1 factorial, 4 factorial. Let's clean that up. That's 24 over 4. Please don't rush too much on these ones because you might get it wrong, right? 5 factorial is 120. Yes, I'm just checking. 120. And 4 factorial, right? 1 times 4 factorial. 4 factorial is 24. So this gives me 6. And 120 divided by 24 is 5. So you get 30 ways, specifically if you go through the store. Sorry about that. So let's do this. I'll give you 1 mark for the 84, 1 mark for the 30, and another mark for the probability. So what does that mean, 1 mark for the probability? As long as I see the 2 numbers being stacked, even if you got NU wrong or NA wrong, I'll still honor you by stacking them correctly. Okay. I wasn't too clear with the previous one, so we're going to go back and assign marks for those. Let's go back up here. This one over here, I'll do the same. Watch. 1 mark for the NU, 1 mark for the NA, and then 1 mark for the probability. So get rid of the 2 marks, right? Get rid of that, and just say that question 2 is worth 3 marks in total. Then I'm going to go further up. For B, I will do this. Watch this. For B, if you need to break this down, it's half for the total, half for figuring out that you need to subtract the no imperials, and then 1 mark, so half, and 1 for actually subtracting. So if you have the 5270, you're going to get 2 marks for sure. And I'll give you another mark for actually stacking. So this is not worth 1 mark, this is worth 3 marks. Okay? That's so A is 3, B is 3. C, this one, I'll just give you 1 mark for actually multiplying, so for finding your NA, and 1 mark for the probability. That one is only worth 2 marks. So C is worth 2. So 3 and 3, that's 6, and 2, that's 8. Another 3 is 11. And then the last question is also worth 3. So we're sitting at 14 for this question if you did that right. So the total is out of 14 for this AC. So let's put that at the very top here. This is out of 14. And if you're not sure, I'm not going to argue with you today. Okay? If you give yourself 13 instead of 12, I don't argue with you. Self-reflection here, self-evaluation. Same answer? How did you... The counting? Like where you actually put the numbers in here? Sure.